Okay, I think we're live. Most likely we're live. I hope we're live. I hope I did it correctly today. I'm quite tired, so yeah. Anyway, welcome to day 29 of studying compilers every day until I land a compiler role. Yeah, today's gonna be a little bit of a shorter stream because yeah, I'm quite tired today for so many different reasons, but the stream must go on, so yeah, I'm still here. I'm still writing code. Yeah, hopefully we're gonna get a little bit more done with the pass manager, but we'll have to see. We'll have to see how much time I can actually dedicate to that. Time flies by? Yeah, it sure does. What's good today? Yeah, let's go leetcode. Minimum number of people to teach. Okay. A social network consisting of M users and some friendships between users. Two users can communicate with each other if they know a common language. You're given N, an array of languages, and an array of friendships. Why is it always 7 p.m.? It's because that's when the daily resets. There are N languages. Each user knows each user knows however many. And then friendships I denotes friendship between users. Okay. And they can only be friends. Wait. You choose one language and teach it to some users so that all friends can communicate with each other. What's good, John? What is happening in this problem? Double ping, okay. Anyway. My Discord is doing strange things. Your hair is more purple? It might just be the lighting, I don't know. Okay. Okay, so friendships is like the edges in the graph, is what I'm getting from this. Okay. So then... Oh, this is awful. This problem sucks. Okay. So you can only choose one language. Okay. So this makes it a little bit less bad. Okay. Yeah, okay. Well, so I mean, we can just go through all friendships. So I'm still confused what this is looking for. If you can only choose one language, choose Rust. True. I'm so confused what this is looking for. Oh wait, I see. Okay. Okay. So let's... So we want each user to be able to talk to all of their friends, it looks like. So if an edge already has a shared language, we can just disregard that one. Okay, I think I have an idea here. So we can iterate through each of the edges, and then if they share a language, then we continue. If they don't, then we add that to a process list thing. So let's start with that. So auto pair and friendships. We want so we want vector int first equals languages at, we want pair 0. Can you explain friend? It is like a method that, or I guess a function that a function that can be externally implemented with full access to private members, if I remember correctly. It's pretty funny. There's like a lot of instances where it's very useful. Like I think, I don't remember exactly. I think toString was a very frequent use of it. I don't remember why, but apparently it exists. So let's second. What's the fast way to do this? I would like to make this a hash map of some sort, but you should fork C++ and make it Buddy instead. I could do that. Or I could just like use a cross compiler and call it a day. What are you writing? Right now I'm doing LeetCode. Outside of this, I'm working on a compiler from C to x86. I feel like I'm struggling with the semantics of this, but let's see. It should be 1. There has to be an easier way to find. We can just, let's make a map first. So auto langs in languages. Let's make a unordered map. We need an index here, I just realized. So we want 0 is less than size. Okay. So let's so we went int to int, I believe. Let's call this nose. For auto in languages I. So for each language in there, we want to add it to that person. So nose. Oh, wait a second. Wait, I'm not doing this properly. This needs to be a vector of unordered map. No, we can just do unordered set of int. Sounds exquisite. I only know Python. It's not even that much. No, you can definitely get to this point. It's definitely attainable. I think the fact that I was able to do it is sufficient proof for that. So nose at I dot push back or insert. We insert lang. Yeah, okay, so we have the mapping now. Yeah, so we have. This is a little bit ugly. Also, it's good, Skittle. It's good to see you here. The pigeonhole doesn't matter here, to my understanding. We're not really proving anything. Nothing is hard in CS except for naming things and cache invalidation? True. I would even add parallelism to that list. Because you start talking like Yoda sometimes. This is not what we want. We want this, and then for I in first, we want to check if it exists in nose, if nose dot find hi. It's not nodes.end. We can right now. Yeah, if that doesn't exist, then we can just break the loop. Wait. Can break, yeah. So you just do an easy using brainfuck? I will pass on that one. Yeah, so we can break the loop here. Right? No, I'm doing this wrong. Yeah, low-key I got bonked over the head by medium earlier today, so I'm definitely not the sharpest here, but yeah. So we have a map. We have a mapping. Maybe I should do this in a different way. Okay, I'm gonna look at the solution here. I'm way too tired. Yeah, okay. Okay, greedy, sure. Okay, so this is basically what I'm trying to do. And yeah, this makes sense. Yeah, I guess that makes sense. After I left last night, I ended up reworking the entire data pipeline. That's pretty neat. What'd you do? Trust yourself, you'll become a compiler. Yeah, that's the goal. This isn't even a traversal problem, I think. I can't read this, I can't lie. What is cncon? Cannot communicate. Okay, I'm overthinking this, it looks like. I'm what? Huh? Okay, so what is happening here? Implement cache side patterns of cron jobs. Ooh. Okay, so what's happening here? Unordered set int. Okay, so this part makes sense. So what is this MP? If they can already communicate. I see, okay. And then is this like, why is this -1? Do you think I got it wrong? I can't lie, I haven't been paying too much attention to chat in general. I've just been trying to figure out what this is saying. I'm also like giga tired today, so like my fault. Okay, let's, so what is this map? Oh, I see. Okay. Yeah, so this is like kind of what I was trying to do, but I was being really dumb with the way I implemented it. Okay, so let's get a pair, and then int first equals pair 0, second equals pair 1, and then we just have to like brute force their friendships. So we could probably do a little bit of caching, but I'll do that after this. So we can, for auto lang in languages at first, we want to, let's make a map. So this is, I can even set, right? What's happening here? Why is there a map? Why? Okay. That's really ugly. Yeah, we're gonna use a set. First knows if lang, or we can just directly add that, I think. First knows dot insert lang. Okay, so then for auto lang in languages second, if first knows, so if it has the language, then we can set a flag and then move on with our life here. Bool cancom dot C++ set. I don't know the API for this too well. Sorry for full blind. Lookup find. Okay. I guess contains. So we don't need to access. Then we can set cancom equals true, and then we can break. Let's default this to false. We can definitely do a little bit of caching, but yeah. So break will get us out of this inner for loop, so then if canonicalization, then we want to cncon cannot. Let's do shared. So we want to do shared at, or shared dot insert. We want to insert first and we want to insert second. Okay, so we have that, and then out of here we can process that shared list. So let's make a map. Shared, or from int to int. This will be res, I guess, or I guess counts. So for auto lang in, what do I call it? Shared. do not ling for auto friend. Or oh, I can't use friend because it's a keyword. Shame. Auto person. So for each person, we want to get their list. Auto ling in person, or yes, in languages at person. Yeah. So after that, we want counts at ling plus plus. Okay. Yeah. So that should count the total number of languages. So then we just return the minimum there. For auto pair in counts, we want to counts at so let's make the result. This is let's make this let's do is inmax a thing? It is a thing. Okay, so we have int max, and then res equals min of res and pair dot first, not second. Alright, let's see if this works. It's gonna be like giga slow if it does work. Oh lord, that is not what I want. Buffer overflow. What's it caused by? Something is causing it. What's going wrong here? Oh, is this a index moment? Is it like this? It really was that, okay. Oh, okay. Why is it 0? Oh. So let's, if so if it's empty, then we want to return 0, I guess. I didn't account for that edge case. So, are you kidding me? Okay. What? That's? Okay, I'm just gonna compare against the solution. I'm way too tired for this right now. What's going wrong here? Auto friendships. So what is happening here? So we mark that. Yeah, we do that. And then do that. If it continues, then okay, we do that. So we're generating that correctly. Why is it max? We should use the... Oh, duh, right. We should use the max because we want to... Because max represents the language that most of these people know. Okay, I see. That makes sense why I'm wrong. Okay. Yeah, so we don't need that. We can do 0. So this is max. And then return counts.size minus res, I think. That should be the correct number now. No. Starts to say no. Why is this one too? Counts? No, counts is not the right one. We want shared. There we go. Alright, now I've missed so much in chat. Let me scroll up for a second. Holy. When was the last one I remember reading? Let me say that while I'm at it. What is the greatest software ever written? Sure as hell not anything I write. If I wrote software that flew planes, I would be scared to ever get into a helicopter. Drink extra coffee? That will not make me more awake. There's a lot of Valorant chat. I'm currently unranked. I peaked Ascendant. It's like doomed, because when I'm like Diamond, I don't care about the game, so I have fun, and then the instant I hit Ascendant, the booger rank just like has a stranglehold on me, and I just like ruin all semblance of fun for myself. Yeah. You can just say JavaScript, true. Return JavaScript, one-liner. Yeah, okay. So this one is done. This reminds me a lot of a bunch of other LeetCode problems. Where the hell I am? Okay. So that's done. And then let's do the pass manager. So it's definitely existing. Don't worry about what's up right now. Yeah. So I got through at least a little bit of the initial build out last time. Or at least like the interface for it. The idea is that the idea here is that analyses is cached, I guess. So the idea, I guess, like we have a bunch of transform passes we want to run on it. So like things like turning stack variables into like real register variables, or like constant folding or like instruction combination stuff, or like loop optimizations. Each of those has its own pass, so then I can like segment it out a little bit easier. And then I can also like mess around with the order that those are run on. Yeah, so those potentially depend on certain analyses. So things like which variables necessarily come before other ones, or which variables require using which other variables, and that determines a lot about what's possible and the types of patterns that we iterate across. So those are analyses, and they don't make changes to the program, but they just like hold information. And the idea is we want to keep them as much as possible, and we want to rerun each analysis as little as possible. The big problem that we run into with passes is that since they can transform the code, there is a chance that they also invalidate an analysis because the code has literally changed. So the idea is to keep analyses separate so that we can kind of run them on demand, and we can treat it like a caching problem. So at each transform pass, the idea is we check the analyses it depends on, and then if that's already been run and is still valid, we can just use that analysis. If it hasn't been run, or if it's been invalidated, we can just rerun it and use that result. And then we can also cache that for next time. And then a nice thing about passes is that they also don't necessarily invalidate the entire analysis, but that's going to take a lot more finagling. I'm going to work on that at some point in the future. That's not really like a first level concern. So the interface, I guess all of the interfaces are designed for that sort of idea around, or an idea around that. I forgot where I was actually trying to implement things. Presumably Pass Manager. Yeah. So we can start here. Add pass, we want to register analyses, and then we want to... So register analyses, the idea of that is to give it all of the analyses that we currently have, or just like the list we have, and then if it doesn't exist in the list, we want to add the new analysis. And if it already exists, we just want to feed that to the, or a pointer to that in the transform pass. And then we can add that to the list of transform passes we have. And then run passes is pretty straightforward. We just rerun if invalid and it's necessary, and then rerun the pass. Have you seen Mangle, Google's new language for database? I have not. I've been pretty disconnected from database land at least. It would probably behoove me to look at it, but there's lots of priorities. So much stuff to look at, so little time. Okay, I think this is a pretty stable interface for the pass manager, so we can start looking at pass at least. Yeah, so run here is pure virtual, so we don't need to worry about that. Yeah, databases are really cool. I just haven't really had the time, unfortunately. So we want void. So we want to implement these two. So let's, oh, we got a namespace. So this is analysis pass. Oh, I need to import, whoops. So this is middle and mir, not mir, pass, got H. That resolves that, and then we can do the same here. We don't want to format that yet, because we want to put things in here. So these are pretty trivial functions. We can just, yeah. So we can just valid equals false. So we want if not valid, then we want to run the thing. So we want to run, we should probably give it the program as well. Yeah, because actually, because the program is not going to change, right? I guess we can make it a private field later if it comes down to that, but sorry, I'm completely in like interview brain right now. I'm yapping like an inebriated person. So we want to run on B, and we should paste that in Yank inside braces, and let's paste. And just, there we go. Managing speed and overall efficiency while scaling is way harder than figuring things out. Yeah, I think that's kind of always how it goes. I think it is still very important to learn the naive way that people do things, at least, because then that sort of motivates the engineering on top of that. And it's also just like really cool seeing like why don't we do this, and then it's like, oh, this part doesn't work, so then it's like, okay, so then we add this to it, and then like that almost works, but then it's like still missing something. It's like wow, so much engineering. Okay, so we have rerun if invalid. We have this this really ugly function that's split on 2 lines. Yeah, so we want register analyses. How do I want to implement this? So get analyses is straightforward. I could do that real quick. This would be it's easier if I just copy like a college student. Let's do that. This is in the wrong place, so let's put that there. Yeah, okay. Return required analyses. Like that? No, we can't do that. Yeah, we can, I think that's fine, right? The United States of America is a country located in North America. True. The next sentence is very much false, though. Silverfish. I'm also a CS student, final year CS guy. Right now it's 6 a.m. and I'm working since the whole night. The grind is on. Damn. That's dedication right there. The NPM thing. NPM. Ah, I see. That's crazy. Wow. Wow, that's incredible. The crazy thing is, like, I recognize like some of these packages just from like some previous open source work I did. Wow. Wow, that's crazy. Yeah, I remember writing I think it was TypeScript bindings for Chalk, actually, because yeah, that's crazy. I was making like open source contributions to Definitely Typed at one point, which is like TypeScript bindings for a bunch of JavaScript libraries. And one of our PL profs, he had this like tool that one of his PhDs worked on at one point, and that like checks the types and checks if they're correct, because it turns out TypeScript doesn't do that for some reason. So there was that tool, and then like the guy worked on it over a summer, and then like I think it was getting to the point where he was making like 10 commits to Definitely Typed, or getting 10 pull requests into Definitely Typed a week, which is like really crazy. He got to like top 50 contributors, but yeah, one of the ones I looked at when also working on that was Chuck. So that's how I heard of it. Yeah, that is crazy. I guess I feel like that's kind of a ubiquitous issue for like most package repositories, though, no? Like, people have been trying to do that on the AUR recently, with like really, really dangerous names as well. Things that look a lot like the real packages. Yeah. So we have get analyses, and then we want register analyses. Oh boy. Okay. I think this might have to be pure virtual. Yeah, this might have to be. And like I might write some macros to do that, but I think this is like the base level of what we need here. Let's just, to try this out, let's make a print pass, I guess. A print pass, do we want just like a constant fold even? Keep going, you'll make you pop up in my homepage, appreciate it. Yeah, npm installs a little bit. It sure as hell is something. Are you using Tableau? No, I am. What is Tableau? Yeah, I don't think I use any equivalent, to be honest. So, yeah. What pass do I want to write first? Is there like an interesting one? Maybe I could do like a canonicalized pass or something. That might be useful because that'll also reduce the amount of work I need to do to write all the other passes. The idea of like a canonicalized pass is you can think of it as sort of standardized. So let's say we have, I'm gonna pull up the paint.net for this. This is gonna be my thing. I am going to be the guy that like scribbles on paint.net. Yeah, so let's say we have an optimization that takes like, what's a good example? We have like, we have a equals add, or we want, let's say this is like a factoring pass, sort of. So we have a equals add, we want molt first, or I guess we don't want molt first. Molt, let's say, molt on ij, b equals molt kj, and then c equals add ab. So if you look at what we're doing here, we have I times j plus k times j. So in theory, we could just optimize this, right? We can just, because multiplies are a little bit expensive, so we can just pull out the j here. So we can turn this into j times I plus k. Right. So this is like fine and all, but the problem is there's like so many annoying additional cases we have to handle. So things like if j and k were swapped, or if I and j were swapped. So it's like things like that you would have to write extra cases for, and we can just avoid this by standardizing the order of everything, I believe. Maybe in this scenario we would have to, but if like instead of j this was a constant, so like 5, and then this was also 5. We can reduce the amount of work we need to do by moving these constants. We can say like the constant should always go to the end if it's commutative. So that is like the rough idea behind this, and why canonicalization is really cool. So that might be a nice first pass to write. Yeah, unfortunately I'm on Windows, but Aiden convinced me to play Valorant last night, so I guess it was the correct choice. What application are you using to write the code? I'm trying to learn Python. I'm using llvm right now, but honestly, I don't really think it matters that much. I used VS Code for the longest time and only switched like last summer. Okay, so let's make canonicalize dot h. Once, and then we want to include this. Actually, we can just include do that. Not MIR, pass. So we can namespace. I'm using copious namespaces. I'm already regretting this choice a little bit, but it is what it is. In hindsight, I should have just used one namespace for the middle one, and then everything else is just good luck everybody else. But we just have to juggle namespaces now, for better or for worse. Okay. So we want this to be a transform pass. Maybe we should make an analysis pass first, now that I think about it. llvm canonicalization. Let's see what they do here. This is Nikita's blog. This is probably good to read. Is this C or C++? This is C++. Yeah. VS Code will last if you want to like be productive with life. If you want to spend your hours re-optimizing your workflow, I would suggest llvm. Why are you using Windows? Because I want to play Valorant sometimes, and I'm too lazy to dual boot. Also, this is full blending, sorry. Okay. Carefully managed. Your hour models, let's see data layout. Who's this handsome fellow and you're recommended? The Rock, probably. Yeah, there's a lot of compiler jobs out there. Even though most of the big infrastructure is open source, there's a lot of like closed source work on them. And like for instance, Apple might need someone to work on specific features for Swift, and then that can be upstreamed into llvm as an example. So it's a little bit of both worlds, I guess. Okay, so where's the canonical form that other passes can depend on? Amenable to further translations and transforms. Yeah, okay. So then backend undo transform. Okay, so then there's like another pass to uncanonicalize, I guess. Okay, let me scroll up a little bit just to figure out what's happening. So data layout, to my knowledge, is like just like literal system, like system architecture specs. So like 32 versus 64-bit, like the size of a long is another good example. Yeah, like little endian, big endian, so on and so forth. Alignment. Low key, I don't really care about this right now, so I might add that eventually, but I think we can just leave that to the backend, and we can just generate target independent code. I've written a compiler and it directly writes an elf file. No assemblers. Would that be good enough? That is at least a start. Yeah, I think there's a lot of like. It depends a lot on like what part of, or I guess like what subset or sub area in compilers you want to get into. Right now I'm just trying to learn more about everything in general. Try exploring Rust. It's really good for developing compilers. Yeah, that makes a lot of sense. I thought about using Rust for this project, but low-key, I feel like I need more C++ practice, and C++ is also just like more frequently used, I think. So from like an employability standpoint, it made more sense at a glance. I have like used a little bit of Rust before, but I'll definitely like try and find a project that I can do that with. Target library info. Which library calls are available? Freestanding. If you need to borrow a Mac, I don't mind shipping mine. I think I will pass. Currently I'm focused more on just like middle end optimizations. Like the one I have like I'm like working on a missed optimization in inst combine just off stream. And it's like my first issue, so I would like to get a little bit of that worked out before I start doing that live. Yeah, appreciate it. Have you heard of MLIR? I've heard of it. I have like a rough idea of like why it exists. I haven't looked too much into the specifics yet though. I see. So this is like intrinsics. Okay. Or I guess like platform intrinsics. So then target transform info provides cost modeling. Okay. As an example. Okay. That seems to make sense. Canonicalization. This is the thing that I care about. And that's like the rest of this article, it looks like. So let's see. So canonicalization passes like inst combine are intended to produce IR in a canonical form that other passes can depend on. That's kind of the thing I was like trying to explain, albeit very poorly. This canonical form is chosen based on how amenable it is to further analyses and transforms, not how beneficial it is for a particular target. Can be undesirable for some targets. That makes sense. Yeah, so it's like we're sort of standardizing it so that the other passes we write have to do less work. And then we have like another backend transform, or I guess transform that prepares for code gen. Why do we go through trouble making inst combine convert IR into one form, then make the backend undo it? Yeah, I guess this problem doesn't really make sense to me. The answers seemed pretty intuitive just because like that's also the entire point of like llvm as well. Like just reducing work by canonicalizing. Like you can think of llvm as like a canonicalized assembly in a way. So I guess that like this seems like a pretty logical extension of that. Yeah, this sort of thing. One direction with inst combine. A single canonical form. LICM. What is this? Oh, loop invariant code motion. Okay, that makes sense. Yeah. Oh, well, I guess it literally tells me. Okay. Okay. PGO. Other transforms can't rely on loop invariant operands being loop invariant. It's not easy to determine. So it's a canonicalization that can be undone. I see. Lip sync in the late middle and optimization pipeline is PGO based, while machine sync is a backend pass. Sure. While legality queries would preferably be answered by data layout, adding a new TTI. What's TTI again? Let's look this up again. Target transfer. Oh yeah, it was above here. Neat. Oh, okay, that makes sense. Yeah, okay. This like makes sense to me at a high-ish level, I think. So in the canonical form, whatever inst combine produces is really funny. Is this about becoming a compiler? No, this is about becoming a compiler expert. Oh, man, I got pranked. Okay. So we should do the thing with fewer instructions if it's not generally more expensive. Interesting. Interesting that this is better. Interesting. Okay. This is like a conversion thing. Okay, that roughly makes sense. Okay, so we can make like a simple reordering pass of some sort that sort of does this. Okay. Let's insert these patterns. Is there not equivalent? Yeah, that makes sense. So you can canonicalize towards that. And then, okay. There's an undo transform. Okay. Okay, that roughly makes sense. I guess per usual, whenever I like look for something online, I'm struggling to like find the actual thing that I want, or I find the answer that is the opposite of what I want, which is, well, this here. Yeah, so I guess I would need to make just an inst combine pass then. I guess it'll be this one. So then, might be another. This might be a little bit of an annoying pass to get right at first then. I've heard of what a dominator tree is. I know that that is important for a lot of things, but compiler dominator. I need to learn about this. I like tried to learn about this and then I didn't. So yeah, this might be kind of important. Yeah. Okay, so okay. So if every path from the entry node to something must go to, so if every entry node, every path from the entry node going to n must also go through d, then d quote unquote dominates n. I think that is what is happening here. So then, yeah, and then this is important in SSA form as well. So then, yeah, maybe I should, that might even be, I might need to do a little bit of reading off stream as well before I implement this. Would be an interesting, easy one to do right now. Oh, we don't have variables. Okay. There's so many different things that I want to do, and so little knowledge to back it up right now. So I guess there's just a lot of learning here today. Let's see. Have you looked at, I don't know how to pronounce that. Let me look it up. Interesting. Yeah, I guess I could replicate something like this, but oh, interesting. Yeah, I would like to replicate a little bit more of the modern infrastructure, at least with this. So I don't particularly intend on copying that, I guess. Okay, well, let's look at SSA construction. Luckily, I have in my library the SSA book. Let me pull this up. Where did this go? It's in here, and then books. Okay, so I've been reading through this. Yeah, unfortunately there's no dark reader for this, sorry folks. I've gotten through at least here, I think. I've like skimmed through construction. I haven't looked too much into destruction yet. Yeah, I think we will start here. So, is there a way I can like make this not miserable to read? Okay, how do I dark mode this? PDF document colors. Edit. We want, where's preferences? If open, go to the edit menu. Where's, am I blind? Oh, isn't it here? Preferences. And then custom color. So this should be black, this should be white. Ah, much better. Okay. Yippee. We can read again. Can we one-page this somehow? Single page. Okay. The diagrams are dark. Damn it. Okay. That's a really big problem. So, yeah. Again, we're just fighting with Acrobat, but that's how it goes sometimes. Okay. I guess I can read that at least. What are compilers? They are programs that, I guess, take a program in a source language and then convert it into some other language. So like, for instance, the one that I'm writing converts C code into x86 64 assembly. Other compilers take different languages and potentially different assemblies. They can also be like, they don't also have to like compile to assembly. Like, a lot of research compilers just compile down to C, for instance, because it's easier. Standard, Yeah. Okay, so then we have like this join set. We have dominant frontier, which is confusing. I wrote notes about this somewhere. Where did I put this? Okay, so a dominator is a node that must be gone through, and the dominance frontier is like the direct descendant of that, I guess, is what I have written down. I don't know a lot about this, so if I'm like incorrect in any sense, and you know that I'm incorrect, please correct me in the chat. Okay. So then, yeah, I walked through this example. This is where we insert fees. We don't need to worry about fee insertion right now because we don't really have control flow. So that simplifies it. Is it something new you're trying to do, like research stuff, or are you trying to replicate something to understand it better? It is mostly just like replicating it. Because there's a lot that I don't know yet. Renaming, okay. So let's do implement mem to edge. Every website is light mode. That really sucks. Okay, so we know what SSA is, we know what control flow graph is. Yeah, that exists. Yeah, okay. So what is the dominance frontier and why do we need it? Okay. This variable may be used as an L value in different branches. So like here. So that turns into that. Yeah, so we do memory things. That roughly makes sense. Yeah, so we want to make those registers as much as possible. We have a fee node. I need to add fees, but I will add fees eventually. When I add if statements, I will add fees. So with a fee, we can make the IR into that. Notice this. This just sets this as like, if it's in this branch, then this variable is this one. And if it's in this branch, then this variable is this one. Okay. Okay, I'm not particularly interested in fee insertion right now. That's something I'll just like reread on my own. Okay. So then, what the hell? Okay, so we need to get rid of loads and stores somehow. Yeah, okay. So where's the part where we get rid of stack variables? Generate by fee or store? Okay, wait, let's go back a little. So we replace with a fee node and then we search along shore. Okay. So I think we can just naively replace things right now, at least. which is really funny. Okay. So, what do we do? Yeah, here we are. I have to figure out where I lived. Yeah, I'm definitely quite tired today, but it is what it is. Let's just make mem to reg a thing. We don't need to call it mem to reg, but I'm gonna call it mem to reg. So this needs to be a transform pass. So we want class mem to reg. This is a transform pass. And then I think I can default register analyses. I had an idea for how to not have to default it, but I think I do have to. Yeah, so we want to implement run. Void run our program p, and this is an override. That needs a semicolon. And then we need register analyses and get analyses. I think we can. Oh, I understand why I didn't default these. Yeah, because this will always return that. The default for this can just be a no op. I don't think I need to register anything, so I can just skip that for now. Yeah, so let's also implement this real quick. Yeah, this goes here. And then, what type was this? Was this void? Yeah, it was void. Oh, I can't type. Whoops. Are we? Oh, it's transform. Whoops. There we go. So that looks good. Let's format that. Okay. So I guess this is a pretty simple header here. This needs to be public. Yeah, that seems solid, I guess. We can leave it like this. And then see that. And then we can get rid of this. What's your background? Where'd you start this journey from? I took our school's compilers class on a dare, and then it turns out I really enjoyed compilers, so I did research. And now here I am, sort of catching up on the work that I neglected to do when I was doing research. Because I want to do more middle end work, and that will require me to understand more of this. Yeah. So from, I guess like, the whole middle end stuff here, this is all completely like fresh ground for me. I don't have like any background for how this is implemented. I have ideas on like how it works, but I don't really know like the internals per se. So what do we want run to do? We want to run this per function, I think. So then it's going to auto f in p dot, this is not a public interface, so we're going to write a couple more getters here, it looks like. Okay, so we want vector functions. This is get functions. I think you're using Vim or llvm like you are. That's correct, but I don't know where and how to build a muscle memory. I think the easiest way to start is using the Vim bindings plugin on VS Code. That helped me at least get used to it initially. Yeah, exactly, or whatever IDE you want to use. Because then you can slowly get acclimated. If it becomes like too much at one point, you can like turn it off. Me personally, I kind of just went straight into llvm. And then just over time, I found things that I was slow at, and then I decided to get better. And I installed this plugin called hardtime.nvim, and this like text at the bottom is a direct result of that. It stops me from doing like really annoying things. So if I were to like spam J or spam K, it like blocks me from doing that too much. Okay, here we need a getter for basic blocks. So this is basic block, get basic blocks. Your virtual pass class not having a virtual destructor defaulted seems like a feature that could be avoided. That's a good call, thank you. Yeah, I ran into that exact problem for one of my visitors actually. So one of my visitors for lowering to MIR, which is what I'm calling this. Okay, so we want to default here. So go here, I guess. Virtual pass. Thanks for letting me on the sub, bro. Hope you make it big. Refer when you get a job. Yeah, I got you. I don't know why I'm going between default and 0, by the way. It made sense in my head for whatever reason. But yeah, so default that. I would probably need to default these as well, but okay. So we want to write more getters. So we need to get basic blocks, and then we need to get instructions. And the instructions already have getters, I think. Okay. So then let's do that. Instruction. Okay. So now we can start doing. I lied. We can't start doing things. We have to implement this. Yeah, compilers are definitely very complex. I can't say I know what I'm doing. Basic block. Okay, I need instruction. This goes here. This. Yeah, these should be references because we want this to be, I guess, mutate-y. Have you looked into binary and their passes? Interesting. I might give that a look in a second. I'm gonna write these getters first though. Oh boy, where am I? Okay, here. What terminal was that? This is West term. Return body, is that what I called it? Get. Oh, wait, I can't do that. Right. Right, this is annoying. How do I handle this? Each instruction is a unique putter. So what is the pretty way to do this? I don't think there's a pretty way to do this, especially if I'm using unique putters. Let's throw this into ChatGPT, I guess. Yeah, let's do that real quick. Yeah, okay. Is this turn complete yet? I think so. Stop using C++, C is so much easier? That makes sense, yeah. I'm only mostly using C++ as practice, I guess. Arena, I haven't heard of it, actually. Oh, interesting. Yeah, that's really cool. That might be something I mess around with in the future. For now, I think I'll stick to unique putter because lucky I'm too lazy to rewrite it, and I also want to reduce the external dependencies I have. Once there is one virtual parent with virtual destructor, all childs naturally get forced into. I see. That makes sense. I could, yeah, that would make sense. Presumably it's just to like register that it is a thing, and then from there, presumably it would be handled. So why doesn't this? Oh, duh. Wait. Yeah. Is this what I'm missing? And then can do this, maybe? Yeah, okay. That makes sense. That makes complete sense. Okay, so that's the getter for instructions. We need to get basic blocks from function. Yeah, let's just steal that. Okay. So this is function, get basic blocks, return basic blocks. Okay, so then we need to get functions. What's good, Niraj? Welcome back. This getter is here. What do I call this? Return functions. Oh, I know why it's not auto-completing. There we go. Okay, so now we can mem to reg. We can do p.get functions, and we can iterate like this. Okay. So we can iterate like this, and then yeah, we will do a little bit of nest mess. I could probably get rid of like one listener by like separating out the function level, because I don't think we would need it across. Do you prefer simple but unsafe pointers or complicated but safe pointers? Well, I've been bitten by the simple but unsafe pointers already. If you remember my semi crash out from when I was like doing the lowering stuff a couple days ago, vector copies will, or because I was doing like a bunch of copies instead of moves, and I think also like just thinking with smart pointers also encourages you to do less copy slush and a little bit more real code, I guess. You should be using asan and ubsan. What for specifically here? Gosh, memory bugs? Yeah, I guess that makes sense. I've just been like occasionally throwing everything through Valgrind, and if there's a memory leak, then I resolve it. So how do I want to do this? Mem to reg. Oh boy. Okay, let's make. I think I'm gonna like call this stream like somewhat soon, so I'm probably just gonna like outline this a little bit, and then I will implement it next time. I'm like quite exhausted, so. ubsan catches undefined. Interesting. That might be useful then. I might get that to use. Do you use GDB for debugging a lot? Low key, I need to learn how to use the debugger properly. So that might be an adventure for another stream at some point, but for now I've just been in print debug land. Okay. So we want a, I guess we can at least scaffold this a little bit. So we want a, map of, so I want a map from values to, I guess like, variable use count, I guess? So what do I want to do with this? Let's look at example output real quick. Yeah, so we have a putter. We have stores. Okay. So what do I want to do with this? So we'd want to keep the allocates in some way, and then we want to replace we'd want to replace the stores with just the actual variables, I guess. And then Do I have a single load in here? Yeah, we do. Load. Okay, so then we can take this value and then we can replace uses of it, to my understanding. Frankenstein comes handy when you multi-thread stuff, though you aren't using immutable trees, so that needs to change. Yeah, that's true. I'm not gonna worry too much about multi-threading for now. That is probably like 5 years down the line issue for me in terms of this project alone. I've been learning it on the side, but it's not really a primary concern. You can try pressing CC in normal mode. So if I get rid of this, oh, nice! I didn't know about that. That's nice. Is the project name PANNICC? Yes, that is the compiler that I've been working on. Okay, so we want. We would want this map to be at the basic block level, I believe. And then I can figure out like fee insertion somewhere. This has the algorithm, the complete algorithm, right? Pressing O normal mode will add new line and indent. Yeah, it does do that. I've been doing that. Sometimes I hit escape and I regret my life. Okay, destruction shouldn't be that bad when I get there. Okay, so this is kind of just like. I guess this is kind of just like reusing. Or the renaming algorithm is what I'm getting. But then, what goes into the fees? I guess I could like temporarily set them to like null pointers, but or I could set them to the pointer of the store. Yeah, I think that might be the clean way to do that. So. Fee insertion, follow the algorithm, generate fees with the store value header. And map JK and KJ with escape. Interesting. I've heard of people doing that. I've also heard like I think it's like control right bracket from what's his name? Sullivan Franklin. I've stuck with escape because I don't I'm not 10x yet. Okay. So we want fee insertion per function, it looks like. And then this will be value renaming, is that what they call it in here? Yeah, so fee insertion and then variable renaming. So we went to map allocs to. How do we? No, because we don't have names. Okay. To current. Yeah, that makes sense. Should I learn compiler theory if I'm going to low level cybersecurity? So I'm biased. I think that you should just like learn it regardless, but I don't think it's like strictly necessary for like cybersecurity. you're more looking at code than, I guess, like doing things with code. You can install tmux on Windows with wget. I prefer Unix. Like, my laptop is running Arch, but I have a Valorant addiction, so I'm stuck on Windows. It just doesn't feel the same. Okay. So how will I handle this with basic blocks? Because I want to write this in a way that I can account for that. Yeah, I agree with that sentiment. Like, it'd be helpful insofar as, like, you learn about the things that a compiler does. Or, like, the things that a compiler works around. But it wouldn't be, like, strictly useful in and of itself, or intrinsically useful. You still learn though. It's pretty cool. Why do you think I'm here? So I'm sure someone's like made some sort of a tmux port. I also know Westterm has its native mux, but I tried using it and it just didn't do what I wanted it to. The persistent sessions are just too good. So how do I want to map this? The thing is, how do I update the fee, I guess, at each use? So each variable its reaching depth is undefined. Oh, DFS, okay. Python's parser, I mean, that's fair enough. Like, even in here, I just use a parsing library, so. Parsing's like, from what I've heard, it's like not particularly interesting, just because like nothing's changed for a while. So I think it's like perfectly fair to use a parser generator. Yeah, tmux just does what you want it to. Everything else is like missing some functionality in some way. And tmux I find is just like more generally used. So like from a blind interoperability perspective, I think it seems like the responsible choice for me. Because I also like for research, which I will be amping up substantially this upcoming year. I think tmux is the only multiplexer that's installed on the research server. So I would probably have to, if I use something else, I'd have to use tmux anyway. So I may as well just use tmux. Where am I? Here I am. Okay, so we want to just, I guess we want to just DFS, huh? It's pretty funny. Yeah, okay. The store pointer? We can't do the store. No, we can do the store. Can we do the store? Yeah, we can do the store. Yeah, and then we can like change it as we go. So then we need to do DFS somehow. So we want to map allocs to what pointer? Last use. How do I like keep them, or like how do I do backtracking here without like making a kajillion copies though? That is like the one concern I have here. Because if we're like doing DFS across these, we'd either have to mutate the singular map or we just have to like make a billion maps, one per basic block, which sounds very irresponsible. So I mean, I can at least do this for now. Stack-based DFS, that's a good call. But that wouldn't solve the memory, or that wouldn't really solve the backtracking issue, because if I were to restore a state after going back up the stack, I would still have to reset the map, right? Do you think assembly is overcomplicated by most people? I think it's just really annoying to read. It's very not human-friendly, and that's kind of the entire reason why more high-level programming languages have been made. We DFS on basic blocks, and then we renaming with mapped, renaming and with mapped, and resetting mapped, or updating mapped. Is there a faster algorithm? Actually, we don't care about speed yet. This seems like the very basic algorithm. I figure it's probably important to implement in some degree. So let me zoom in, because I realize this is tiny. And for those who are less familiar with compiler terminology, reaching definition is like, I guess it's like kind of self-explanatory. It's like the definition of a variable that reaches the current point. So like if you have x equals 0 and then x equals 1, and then like a print, the x equals 1 definition reaches the print, but the x equals 0 does not. Okay, so we iterate across instructions. Oh. We need a stack. For each variable used by a non-fee function. So used by the non-fee. We want to update its reaching definition to be that. And then we replace this use with the previous reaching definition, I think. Is this West term? Yes. Yeah, I think that understanding of assembly is about right. Yeah, there's a lot of different like architectures for assembly, and then there's like, even on top of that, there's like different operand orders as well. Something about AT&T, and I forgot who else it was. So sometimes it's like source destination order, sometimes it's destination source or something like that. Or is it like right to left, left to right? I don't remember, but yeah. So for each variable used by the instruction. Oh, and then we just update the fees as we go. Okay. In direct successors. Okay. So update the reaching definition, we replace that. Oh, what did I do? Anyway, that makes sense. So then for each variable defined. So, okay, so this is R value, I guess things to the right side of the equals. I hesitate to use R value and L value specifically. So uses and definitions. So for each definition here, we want to update the reaching definition. We make a new definition of a variable, and then we replace the variable. And then we change the reaching definitions to include that, I guess. Is math neutral in compiler theory? I think at least some foundation is important. Because like all the middle end stuff is algorithms, all the back end stuff is algorithms. All the front end stuff is algorithms even. Like to understand what's going on, like you need to understand a lot of math. Are you writing compiler for any existing language? Yes, it is a. I clicked the wrong tab. It's a very narrow subset of C, so yeah. For each variable defined. So the reaching definition of that is the reaching definition of. I see. Okay. So then the reaching definition of the previous one is this? Are you employing heap allocation? I don't have memory yet. Currently, I just have function calls and functions without parameters. Parameters shouldn't be that hard to add, but I'll worry about that later. So yeah, I just have function calls and then like basic arithmetic. I don't have control flow. I don't have memory. I like technically have memory in the sense that like we have stack variables being made, but I don't have like memory. Oh wait, what? So we substitute out the variable, and then I see. Okay, so we're just like literally making a new variable. Yeah, this is a C-like compiler. The code is like I have like a couple of tests written by hand in here, and by a couple I mean like 2. Oh, I lied. I only have 1, but yeah. Oh, do I need to pull? Wait. Uh-oh. Okay, well, looks good to me. Yeah. This is like kind of the rough ceiling of what you can do here. And then there's like function calls, but that's it. Math isn't needed until you need it, true. Okay, I'm gonna... What page is this? This is page 29. Just look at page 29 of SSA book, man. Okay. Okay. We can just do this, and then these are the initial variables. Yes, we can just do that for now. Yeah. So I think this is probably a good place for me to leave off today. I'm supposed to get dinner with people in like 10 minutes, so yeah, let's add stuff. So all the MIR stuff, that's just getters. Why don't you use Arch? My laptop has Arch, but I want to run Valorant on my PC, so unlucky me. Yeah, let me just commit everything first. So this one is add getters to MIR. And then Yeah, Hyperland, we up. So this is without pass. Okay. So yeah, that's everything pushed. Yeah, all of this is public on my GitHub. So if you're curious about the stuff I built out so far, feel free to give that a look. Yeah, I'm gonna call the stream here today though. I'm quite tired and quite hungry. Yeah, thank you all for showing up. Make sure you like the stream if you haven't and sub to my channel. While you're down there, you should also join the Discord. That's the best place to get notified when I go live and to chat with other members of the community. And yeah, add me on GitHub, connect with me on LinkedIn. Yeah, take care y'all, take it easy, stay hydrated.